We are looking at 1-6, day 2 today. We are solving absolute value inequalities. So the question posed is, how do you solve an absolute value equation or inequality? So what we're going to be able to do by the end of class today is solve an absolute value equation involving an inequality. You are going to hear me say over and over and over again, great or means or, less than is and, because that tells me what type of problem this is. So in the previous section, we talked about inequalities, and if they were an and inequality, then the solution set overlaps or intersects. An or inequality is opposite or either, meaning that they don't have to overlap, but they can. So what we're going to do today is compare these absolute values. So the key idea is being able to understand that if the absolute value of x is greater than or equal to some number k, then this is an or problem. So the absolute value is great or than equal to. So it splits into an or. So we're going to have to learn how to split our absolute value equations. The second part of the inequality is going to be the absolute value is less than, which makes it an and. So when we split it, they become an and problem. So we're either going to split to an or split to an and. So here in example number 8, because again, today is a continuation of the other day, we have the absolute value of 2x minus 5 is great or than 3. So it means that when I split my absolute value, the absolute value is going to split into 2x minus 5 is greater than 3, or 2x minus 5 is less than, because you flip the sign and change the sign. So you flip the inequality and change the sign. So your or is 2x minus 5 is less than negative 3. Now it's just like what we did the other day. You're going to solve the inequality for x. So you add 5, divide by 2. So I get x is greater than 4, or x is less than 1. So it's an or problem, so they can be opposite or overlapping. In this case, if we put on our number line 0, 1, 2, 3, 4, 5, and 6, I have x less than 1. So it's an open circle at 1, shading left. Or I have x greater than 4. So it's an open circle at 4, shading right. So I have open circles in opposite directions. So my solutions are x less than 1 or greater than 4. That means if I picked a number anywhere in this shading, I could plug it into the original equation up here, and it would be true. So I can pick anywhere from this shading and it will make that equation true. Number 9. We have the absolute value of 2x minus 3 is greater than 7. So this becomes 2x minus 3 greater than 7, or 2x minus 3 less than negative 7, because anytime you get the opposite sign of the absolute value, you change the direction of the inequality and the sign. Now we solve for x, so we add 3, divide by 2, you get x is greater than 5, add 3, divide by 2, x is less than negative 2. Now again, we don't change the direction of the inequality because we divided by a positive, not by a negative. So you have x is greater than 5 or x is less than negative 2. You knew. Ran out of room. So open circle in negative 2, shade left. Open circle at 5, shade right. Questions at all on either or absolute value? So again, greater is or. Just like with absolute value equations, in order to solve an absolute value inequality, you have to isolate the absolute value, which means that I need to first subtract 5. Then divide by negative 2. So I get that the absolute value of x plus 1 is less than or and 4. So you can't get the and or the or till your absolute value is isolated. So we get x plus 1 is less than or equal to 4, and x plus 1 is greater than or equal to negative 4. Subtract 1 from both sides. And I get that x is less than or equal to 3, and x is greater than or equal to negative 5. So what that means is that x has to be smaller than 3, but bigger than negative 5. So again, when you're writing numbers on your number line, you don't have to write every number. You'll notice I kind of went every other and wrote the odds. So like here's my 1, I skipped writing 2, wrote 3, skipped writing 4. Just make sure you're consistent. So it's a closed circle at 3, closed circle at -5. And because it's less than -3 and greater than -5, I shade between them. In 11, first you have to add 7 to both sides. Then we get 5z plus 3 is less than 41. So less than is and. Split it, make both sides simplified, and then solve for z. And I know that when we get decimals, it freaks us out. Decimals are okay. So you should get 7.6 and -8.8. So what that means is that z is less than 7.6 and greater than -8.8. Because all and inequalities can be written as a single inequality. You don't have to write the singular, but you can. Okay, so at -8.8, it's an open circle. At 7.6, it's an open circle. And you shade between. Okay? Find the absolute value inequality statement that corresponds to -2 less than x less than 4. So sometimes you're given a solution and you need to come up with a problem. So this starts as an and equation. Since I have one answer, it is an and. We want to look at how far apart -2 to 4 is. So the absolute value of -2 is 2. The absolute value of 4 is 4. That means the distance between them is 2 plus 4, or 6. Dividing that distance in half, we get 3. So what that means is that the midpoint of these is 3 to the right and 3 to the left. So what we want to do is find a new midpoint or a new equation by moving our graph. So we can add 3 to every piece of the puzzle. And then since this is an and inequalities are less than is and. So we're going to pick the less than part of the equation. So x plus 3 is less than 7. So we can say that the absolute value of x plus 3 is less than 7. And that would create our absolute value equation. Let's try it again, but with an or. So you have x is less than 19 or x is greater than 24. So the first thing you want to do is find out how far apart are they. In this case, there's a distance of 5 between 24 and 19. Half of that distance is 2.5. And then you add that distance to your original endpoints. So you have x plus 2.5 is less than 21.5, or x plus 2.5 is greater than 26.5. Since this is an or problem, we're going to use the greater part of the equation to turn it into an absolute value. And there's our new absolute value inequality equation that represents that solution set. That absolute value would give you that solution set. So basically, we are finding an equation given a solution. So your homework is those problems on page 45, 16 to 22.